This is the Wixey Mini Digital Height Gauge. For only $25 on Amazon, this is a surprisingly repeatable and accurate way to measure length, width, and height. The red arrows are pointing to the magnetic feet of the Wixey Digital Mini Height Gauge. Putting the height gauge on a steel surface holds the gauge in place for good repeatability. The Wixey Digital Mini Height Gauge is best used with a steel base like these precision ground 1-2-3 blocks. Now we will calibrate the Wixey with gauge blocks. 250 thousandths of an inch, 500 thousandths of an inch, 750 thousandths of an inch, and 1 inch. The Wixey measures in increments of 2 thousandths, not 1 thousandth. You'll notice that the gauge reliably returns to 0. That tells us repeatability at the reference plane is good. At 250 thousandths, the gauge reads 0.250 exactly. At 500 thousandths, the gauge reads 0.498. That is 2 thousandths low. At 750 thousandths, the gauge reads 0.748 or 748 thou. At 1 inch, the gauge reads 0.998. So, what we're seeing is a consistent 2 thousandth difference at several heights. At first glance, that might look like an accuracy problem, but that interpretation would be incomplete. Gauge blocks are accurate to millionths. The Wixey is not resolving millionths. It is grouping real-world positions into 2 thousandth bins. So a true 0.500-inch block can legitimately display as 0.498, depending on where the internal boundary falls. This is digital quantization, not a defect. What digital quantization means? Digital quantization is the process of converting a continuous, real-world physical quantity into a finite set of discrete digital values. In plain terms, the real world is smooth and continuous. A digital instrument can only report in steps. Every digital measuring device has a smallest reportable increment, called its least count. Anything that falls between those increments must be rounded or grouped into one of them. Imagine a ruler that only has markings every 1/8 inch. The only values that ruler can report are 0/8, 1/8, 2/8, 3/8, 4/8, 5/8, and so on. If an object is exactly 1/2 inch long, which is 4/8, the ruler can report that value exactly. If an object is exactly 5/8 of an inch long, the ruler can also report that value exactly. Now consider an object that is 9/16 of an inch long. 9/16 equals 4 5/8, which lies directly between 4/8 and 5/8. Because the ruler has no marking at 4 1/2, it cannot report 9/16 exactly. Digital measuring tools behave the same way. A digital height gauge that reports in 0.002-inch increments can only display values like 0.498, 0.500, 0.502. If the true height is 0.4995, that number does not exist in the display system. The internal measurement must snap to the nearest available digital step. That is called digital quantization. This is why a true 0.500-inch gauge block can legitimately display a 0.498 on a digital comparator with a 0.002-inch step size. The instrument is not drifting, and it is not wrong. It is snapping a continuous physical value to the nearest representable digital increment. Understanding that snapped behavior is the key to interpreting digital measurements correctly. Quantization error versus measurement error. This is an important distinction. Measurement error means the instrument is wrong. Quantization error means the instrument cannot represent finer detail. Quantization error is predictable, bounded, repeatable, and symmetric around the true value. It is not a defect. How much uncertainty quantization introduces? For a digital instrument with step size delta, quantization uncertainty equals plus or minus delta over 2. For the Wixey digital mini height gauge, plus or minus 0.002 over 2 equals plus or minus 0.001 inch. That is the best case uncertainty, even with perfect technique. Why this matters in real work? If your tolerance is plus or minus 0.005 inches arrow, quantization uncertainty is acceptable plus or minus 0.001 inch arrow. Quantization dominates and the tool is unsuitable. This is why digital comparators are used for setup, relative measurement, go/no-go checks, but not for certifying tight absolute dimensions. Why the Wixey Mini Digital Height Gauge? Plus gauge blocks make sense for plus or minus 0.005. Work, the Wixey Mini provides stable, repeatable measurements in 0.002 inch increments, which is well matched to a plus or minus 0.005 inch tolerance band. Digital quantization limits absolute resolution, but the quantization uncertainty of plus or minus 0.001 inch remains small relative to the allowed tolerance. Gauge blocks provide a trusted reference, allowing the height gauge to be used as a digital comparator rather than a standalone measuring instrument. Frequent zero checks against gauge blocks quickly reveal drift, setup error, or technique issues before bad parts are made. Relative measurement and consistency matter more than absolute numbers when holding mid-range shop tolerances. The magnetic base improves repeatability and stability during setup and comparison checks. This combination supports fast setup, repeatable inspection, and confident go/no-go decisions without the cost or fragility of high-end metrology equipment. Bottom line, used as a comparator and routinely verified against gauge blocks, the Wixey Mini Digital Height Gauge is a practical, cost-effective solution for machinists working to plus or minus 0.005 inch tolerances.